Alright, today we are going to start talking about compound inequalities. Compound inequalities is where you have one or more inequalities together. If you take a look at your first example, you see you have n plus 1 is less than or equal to negative 3, or negative 4n is less than negative 8. So we essentially, in one problem, have two of what we've been doing the past 2 days. So we're going to approach this just like a regular equation. We just have two of them. So on this first one over to the left, I have n plus 1 is less than or equal to negative 3. I'd like to get n by itself. So I'm going to subtract 3. So n is less than or equal to negative 4. Or I have negative 4n is less than negative 8. Now I rewrote that because I'm running out of room, and I want to manipulate that expression because I want to be able to solve for my n in this example. So I'm going to divide both sides by negative 4. So n is greater than or equal to 2. Remember, divide by negative, flip your sign. So that's saying that either whatever I'm looking for, so say I am talking about owing someone money, and I don't remember how much I paid them. Either I owe them less, or excuse me, either I owe them more than, that's the way to purchase. I borrowed a lot of money from them, so I owe them a lot of money, because remember, the farther away from 0 you get on the negative side means that you borrowed a lot more money. Or I actually accidentally gave them a little extra and they owe me some money. So I'm going to have two inequality graphs just like I have inequalities. Now, when I have an OR problem, my answers are going to go opposite of each other. So the circles should be facing each other, the arrows on opposite sides. Gotta pause, I got to go check my lunch. Sorry about that, guys. Made a little bit of a weird sound, so I wanted to go check that out, but we're all good. So let's get back to my compound inequalities. So I see in number 2, I have another OR statement, so I'm going to essentially solve two equations here. I see a nice little fraction, so I know that to undo fractions, I multiply. That's 4. So my 4 cancels out, and I'm left with k is greater than or equal to 1 times 4 is 4. Or I also see I have another fraction. I'm going to multiply both sides by 3. 3's cancel out. I'm left with k is less than or equal to negative 3. So when I do the graph on this one, I don't have my numbers in the correct order, so to say. My first one is talking about 4, which is right here. It's great. It's going to be greater than or equal to, so I have that filled in circle. And that purple part is going to get shaded to the right. When I'm looking at the second part, I'm going to have a filled in circle over negative 3 pointing to the left. So in my first example, my negative 4 was already on the left side. I can kind of already see where I was going. However, my negative 3, even though it's smaller, was just on the right side. So just making sure that we make our signs go the correct way. And we can find the correct number on a number line. So those are how you approach OR problems. 3 and 4 are considered AND. They're going to be what you do to one side, you do to both sides, or kind of everything. So if you notice on number 3, I have 2 is less than 2x is less than x. Well, I want that x in the middle to get by itself. So if I cover up my 2 and my 6 for a moment, so do that on your screen, cover them up. If that was just a normal 2x, how would I get x by itself? What would I do? Well, I would divide. And I would divide by 2. So when I do it here, I need to divide every single p's. 2 divided by 2 gives me 1. 2x divided by 2 gives me x. And 6 divided by 2 gives me 3. Now, again, I did not divide by negatives, so I keep my signs the same. On the last two examples, my arrows went opposite, kind of butted against each other. When I have ands, they're going to go towards each other. So I have 1, open circle at 1, and an open circle at 3. I'm going to shade in between those two circles. So they're going to go towards each other. Because if I split this apart for a moment, I have 1 is less than x. Well, my x is on the right side, so I'd have to rewrite it and get x is greater than. If I split this part over here, my x is already there, so it's already telling me it's going to the left. So when I'm dealing with my and signs, I'm going to have my shading go towards each other. When I'm dealing with or, they're going to go away from each other. And together, or away. I have this nice little hand sign that I use, but you can't see it, obviously. I'll just show it to you guys sometime. So let's take a look at number 4. If I cover up my stuff on the outside, I'm left with x plus 6. How do I undo that plus 6? I'm going to subtract it. All 3 parts. 6 minus 6 is 0. 0, not a weird looking 6, I'm sorry. 0 is less than or equal to x, because it's by itself now, which is less than or equal to 5, because 11 minus 6 is 5. So I'm going to have a closed circle over 0. I'm going to have a closed circle over 5. I'm going to shade in between these two. All right, number 5, apologize. Number 5 is going to be an example of an and problem, because I look and I see A, I don't see the word or, that's a good indicator, and B, I see 2 inequality signs with only 1 variable, so therefore it has to be. So I'm going to take a look at my middle. I have m minus 5, so I want to get that away from itself. I'm going to add 5. Whatever I do to one side, I do to all 3 sides. Negative 3 plus 5 gives me positive 2. I didn't divide or multiply by a negative number, so I can keep my signs. Negative 1 plus 5 is 4. So I have an open circle over 2. I have an open circle over 4. And a shade in the middle. Number 6, I see the word or, so I already know I'm going to be facing 2 opposite ways. We're going to have one going this way, one going this way. So let's take a look at that first part. I have p plus 4 is less than or equal to 1. So I'm going to subtract 4 to both sides. So I get p is less than or equal to negative 3. I did not multiply or divide by negative, so my sign stays the same. On the right part, I have p minus 1 is greater than or equal to 1. So I'm going to add 1 to both sides. So then I have p is greater than or equal to 2, because 1 plus 1 is 2. Again, I did not multiply or divide by a negative, so my sign stays the same. So I'm going to be a closed circle at negative 3, going to the left, and a closed circle at positive 2, going to the right. So and will go together, or it goes apart. Pretend I'm doing that with my thumbs up, so and my thumbs go together, or my thumbs go away. That's kind of how I think about that. All right, number 7 is a little bit more intense. It's got a couple extra steps with it, right? My n is not just either added or subtracted. It's got multiplying and subtraction with it. So just like if this was a normal equation, I would start by first getting rid of my addition or subtraction with the n. So I have minus 12, so I'm going to add 12 to both sides. So I get negative 21 is less than or equal to negative 7n, which is less than or equal to 14. I don't know why I wrote that so far away. Excuse me about that. So next I notice is I'm going to divide by 7. Excuse me, negative 7. Because I have that negative 7 times my n. Negative 21 divided by negative 7 gives me positive 3. I'm going to have n in the middle. And 14 divided by negative 7 is negative 2. Now, if you forgot and just left your signs the same as what you saw in the red step, ask yourself, does that inequality make sense? Is 3 less than negative 2? Is negative 2 bigger than 3? Hopefully, you are all saying, no, that doesn't make sense. 3 is bigger than negative 2. Well, it is. So I need to make sure I flip my signs so everything makes sense. Now I see correctly that I see 3 is larger than negative 2. 3 is larger than negative 2. We're all good in the hood. So I have a closed circle over negative 2. The reason it's closed is because this sign, which is the closest to the negative 2, is equal to. And a closed circle over 3 because the sign is equal to as well. My answer is just shading in the middle. Number 8 is, again, a little bit more intensive, but nothing you can't do. I want to get b by itself on that left side, so I'm going to subtract 9. So I have 2b is less than or equal to negative 2. To be or not to be? That is the question. I'm going to divide both sides by 2. So b is less than negative 1. Now remember, I did not divide by a negative, so my sign stays the same. Alright, on the second part, I have to undo my addition, so I'm going to subtract. So I get negative 5b is less than negative 15. I'm going to divide both sides by negative 5. b is going to be greater than positive 3. Again, if you forgot to flip your sign and you left it as less than, this green line already tells me I'm going to go to the left. And then this one would be going to the left as well. We don't have, in these two different types of inequalities, anything going the same way. We don't have something like that. We have opposites. Either they are going away from each other, or they're going towards each other, but they never are going the same way. If you get to the point where you accidentally have your arrows going the same way, then what you need to do is go back and say, well, hey, did I forget to divide by a negative and flip my sign someplace? Excuse me, 9 times out of 10, that's going to be your problem. Alright, so I have an open circle at 1 going to the left, and an open circle at 3 going to the right. You can do these. I promise you. I want you to try them. Come back when you have it finished. So make sure you pause your video. Alright, so number 9 probably threw you for a loop for a second because it says the word and we haven't seen those with the word and, we've just seen them compoundly. So we're just going to start them exactly the same and make sure that my signs are all going the correct way. So I'm going to go ahead and subtract 9 to both sides. So I have negative 12r is greater than or equal to negative 108. No, 7. I can add sometimes. No, it was 8. 108. So 109 is not divisible by 12. Come on, Miss Kimmy, get your head in the game. Then I'm going to divide both sides by negative 12. So r is going to be less than or equal to 9. So I did that first one, so let's do that second one. So I need to add 4 to both sides. And negative 2r is going to be less than negative 8. Divide both sides by negative 2. R is going to be greater than positive 4. So let's double check by graphing, make sure we got it going the correct way. Now these are going to be an and problem, so they should be going towards each other. So I have R is open at 4, going that way, to the right. And I have a closed dot at 9, going to the left. Oh hey, they're going towards each other. We solved it correctly. Now I really want you to do number 10. So if you've already done number 10, great, excellent. Just give me a couple seconds while I get it done myself. Alright, so you should have number 10 looking like the following. If so, excellent. If not, go ask your teacher for some help. Try it again, see where you might have gone wrong. Alright, that's all I have for you.